What's up, guys? This is Corey here with Toothless Reptiles in San Diego. Last time I was in this enclosure doing a video, it was not a good video. It was not for good reasons. But today we're going to do a video, and as a lot of people you may have seen if you follow me on Instagram, Twitter, YouTube, or you check out my website or our Facebook page, you've seen that we have a Parthenogenesis egg hatching right now, and I had a lot of questions from people asking exactly what Parthenogenesis is. Sorry, I'm kind of yelling because the water filter's on, but so I did a little write-up on a lot of the information that's out there, kind of some basic things that you might not know that you should probably know about Parthenogenesis and genetics between monitors and snakes and birds as well, which is important. And then this is just my own personal experience with Parthenogenesis and how I have interpreted the information that's out there right now. Obviously, you can do your own research and figure everything out for yourself. And this is more meant for the people who really follow me on Instagram and all those other places. You know, the kids who have, say, a Nile monitor or Savannah, or who are just interested. They never heard the term Parthenogenesis before. You know, this is for you guys. So, what is Parthenogenesis, and what do we know about it? Well, Parthenogenesis is when a female produces viable embryos, aka babies, without the sperm of a male. We know that monitors do this pretty often, especially notable with Komodo dragons in the wild and in captivity. Komodo dragons have been proven to produce males and females that mostly or only contain genetic material from the mother, but it is important to note that these reptiles are dying off and are endangered. They are not thriving in their natural environment. This form of deliberate parthenogenesis is being performed to ensure the survival of their species. These Komodos in the wild are obviously not being fed rats and chicken legs and chicken feed, and they're not being loved all the time, and they're not in a low stress environment. Our captive born and bred monitors that we have are obviously in a much more thrive-friendly environment. What we know about monitors is that the females possess a WZ chromosome as opposed to an XY that you would see in a human, which allows them to duplicate these chromosomes to create viable eggs without a male that would normally introduce another set of chromosomes. In particular, this allows a female to produce a male. By duplicating her Z chromosome, she can create a ZZ male water monitor. I think a common misconception is that monitor lizards are the same as snakes when it comes to parthenogenesis. This is not the case. Most any snake breeder will tell you that parthenogenesis happens very often in snake breeding, and it always produces females, which is something that is obviously not the case in monitors, especially. Also, endomitosis is what is most common in reptiles, and this is when a female is produced that's almost identical to the mother. In most DNA testing of male monitors produced from parthenogenesis, the genetic material does differ from the mother. It's not all from the mother, or at least it's not a direct copy. In reality, birds are a closer relative to monitors than snakes, and that's why the most recent study done in Germany actually used turkeys to increase their sample count. A quick abstract of the study: a recent study done in Germany by Ralph Winkman used Argus monitors to try to shed some light on parthenogenesis in captivity. A quick abstract of the study: two individually housed females produced a total of 14 clutches of eggs in the absence of a male over a period of 7 years. To date, 23 out of 69 eggs received from egg clutches have been incubated. All other eggs were noticeably infertile and discarded. Embryos developed in at least 10 eggs, 9 of which died shortly before hatching. Only one offspring successfully hatched and survived. 2 non-surviving embryos had physical deformities. During this study, they were able to bring a living embryo to term for a long period of time until they began to stress the females out considerably. They cut back the food intake and forced them to chase their food almost to exhaustion or until their feeding response subsided. This tactic worked because it forced the female into a deliberate parthenogenesis state where she was now biologically trying to ensure her survival by producing a male, which she did. This was supposedly not the reasoning behind this change in husbandry, but it worked either way. The only monitor that hatched was a male monitor with a ZZ chromosome. And it's believed that the other monitors that died during incubation possessed a WW chromosome, which would be a female, and they were incapable of living to term. This was, however, not substantiated. Actually, none of the dead monitors could be sexed, and there were a lot that were physically deformed or did not have a proper yolk sac. The basic logic behind this study and its results is that a female has a WZ set, and since she can only duplicate one of her own chromosomes, she can only create a WW or a ZZ. And in nature, a male water monitor has a ZZ, naturally. And normal water monitors don't have a WW. So for a female water monitor to create a WW, it's kind of going against nature and they don't end up viable. But they do create a ZZ, which is a normally occurring chromosome pairing, and that creates a male water monitor. I suppose the simplest answer to parthenogenesis and whether it's male or female is that there isn't one. We know that monitors can produce young without sperm, and they can produce both sexes without sperm. We also know that they have more control over themselves biologically than we will ever be able to understand. After talking to multiple breeders about their experience, the results were varied quite a bit. Some producing males and some producing females, and no one I spoke to was interested or had done DNA testing. And on top of that, the DNA material of a ZZ chromosome carrying parthenogenesis baby is not identical to its mother, but it is very similar. It's similar enough to know that it's a parthenogenesis baby. If you do DNA testing or comparative testing of two monitors that are supposed to be, a monitor that's supposed to be partho from a mother, if you receive more than 50% at all, 51% of that genetic material that came from the mom, then you know it was a parthenogenesis baby. Aside from whether you had possibly bred them to siblings, which would skew your results obviously, but generally speaking, if you have more than 50% that came from the female and that's verified by a DNA testing, you have a parthenogenesis baby. To touch base real quick on sperm retention, because that's been coming up a lot, there's a lot of people that are skeptical about the parthenogenesis. I don't know why. You know, it's really common. In my experience, it's more common than sperm retention, but honestly, I don't know, because I literally only deal with the water monitors, and I've been doing this for a long time, but I've also only been doing it privately. I just started branching out into the public about a year ago when I created Toothless Reptiles. So I don't have a lot of data from other breeders to, I guess, reference during this. But in my experience, parthenogenesis is actually pretty common. But sperm retention is commonly an elective procedure by a female who is not in a good laying condition and does not have the opportunities to produce. Sperm retention also does not usually discriminate between clutches. If a female happens to retain sperm in captivity for whatever reason and is given a good laying condition on her next clutch, she'll more than likely use the stored sperm. This also produces a high fertility rate. In theory, a female can produce an entire fertile clutch from sperm retention. So you may have a female that breeds one time with a male and retains sperm, and the next clutch she lays, you haven't had her in with a male, and she may lay another entire fertile clutch. And because with sperm retention, there's a very high fertility rate. Now, if you have a female monitor that lays 20 eggs and only one of them is viable and only one of them hatches, chances are that monitor egg did not get fertilized from the one random sperm that she happened to have retained along however long she's been without a male. I mean, chances are it's a parthenogenesis egg. So let's see. It's more likely that the egg was hatched due to parthenogenesis. In either case, DNA testing is our only way of looking into this complex process. Whether sperm retention, parthenogenesis, or endomitosis, it is safe to say that monitor lizards are doing some amazing things with their bodies, in particular their reproductive systems. For us to even begin to understand what's happening is a huge task. These little guys that we love and keep have more control over their bodies than we will ever know, and to venture to guess what we think we know about them without doing our due diligence and using the technology we have would be a great disrespect to our pets and our field. Hopefully I can continue to bring more data into the mix with these little guys, and all the breeders out there can continue to shed a little light up these scaled skirts. So, you know, that's a little bit about parthenogenesis and my personal take on it. It's not that complicated. It's just, it takes a process to prove, because if you have a female, anybody can say that, okay, well, when that female was born, it got sperm from somewhere. So without DNA testing, everything's skeptical, and nothing can really be disproven. At the same time, nothing can really be proven also. So this isn't really to prove anybody wrong or to prove anybody right. I just wanted to get the information out there so you guys had a little better understanding of what parthenogenesis is, because we actually have some black dragons hatching at the beginning of July that are a parthenogenesis clutch as well. And that one is for sure 100% parthenogenesis. That one was actually never in with a male at all, ever. So we'll see what happens, but we're going to have the DNA testing done. We'll bring the hatchling and the mom Yoshi in, and we'll have them all tested, and we'll compare the DNA and see if hopefully all the genetic material came from the mom. And even if it didn't, you know, like, it's still cool that to be able to prove sperm retention. You know, I don't care, it doesn't matter to me, but right now all the facts that we have on my end with my breeding projects points to parthenogenesis. So that's kind of what we're going on. If I had anything to point towards sperm retention, I'd love to be able to say it was sperm retention. You know, I really have no idea. And nobody does until we do the DNA testing. So hopefully I'll get that done, and I've already talked to who I needed to talk to, and we're going to schedule it out. And hopefully the results, usually the results take a few weeks, which is understandable, but yeah, we'll see what happens. And shout out to Vince and Moses. What? And thanks again for all your support, guys. All the comments I get on Instagram and YouTube, and the questions and stuff I get on Facebook are really cool. And when people direct message me and ask me questions about things, like, I'm always excited to talk to you. And feel free to email me, Corey@toothlessreptiles.com, if you have any other questions. And you know, I just love doing this stuff with you guys. It's the coolest hobby I have. So it's really neat. So I appreciate all the support. And as always, keep feeding.